For Mini Challenge 2, we designed a vectorial temporal system, WindNebula. WindNebula blends key information from different variables and reveals hidden relations among locations of factories, sensors, pollution intensity, wind direction, and sensor problems. Our system has two major interfaces, vectorial view and temporal view. In the vectorial view, we call these white circles nebulas. These nebulas are placed on the sensor's actual locations on the map. This placement facilitates the perception between the factory emission and the sensor readings. The nebulas use a polar coordinate system. The radial coordinate of dots represents pollution reading, and the angular coordinate is the downwind direction at the reading recording time. The wind heat map used the polar coordinate system to show wind speed and direction. It explains why there are not many readings on the southwest corners of the nebulas. Users can filter the plot by chemical or by month. Apparently, sensor 9 captures apple ammonia discharged from indigo soil bores, while sensor 6 captures chlorine discharged from Roadrunner Fitness electronics and methylasmine from KCL's office furniture. Also, some sensors are not working correctly. For example, sensor 3's readings are significantly higher than its neighboring sensors. When click a sensor, a detailed view will pop up. The three nebulas represent 3 months, and the background are the wind heat maps of the corresponding month. The wind timeline in the middle overviews the trend of wind speed and direction over time. The curve shows the speed variation over time. Ribbons attached to each moment show the directions. At the bottom are the temporal scatter plot of sensor readings. The lines represent multiple readings at the same time, and the hollow circles represent the missing data. While being hovered, readings with corresponding time moment from different plots will be highlighted for pattern seeking. To see more details, we can switch to the temporal view. The upper left plot has the same format as the last pop-up page. Besides chemical filters, users can toggle between 24-hour and 31-day time span, linear axis, and logarithm axis. The slider serves as an axis for 4 different chemicals. The statistics on the right side show the average readings at weekday, weekend, daytime, and nighttime. The bottom plot shows the temporal patterns of all 9 sensors. Users can click the titles to check details in the upper plots. This view allows us to compare temporal patterns of sensors and identify events. We can notice that sensor 4's baseline is consistently shifting. Also, AGOC's readings were recorded twice for some moments, while corresponding methylasmini's readings were missing. These errors have strong coincidence and happen at all sensors. From this case, we can speculate that methylasmine was misreported as AGOC. Synthesizing spatial, temporal, and vector information, WindNebula helps analysts identify patterns, anomalies, and errors.